Now that we know what a binomial experiment is, we want to know about the probability of a binomial experiment. So how do we find the probability of a binomial experiment? Well, that can be quite complicated, but luckily we do have a formula. It's just, like I said, a slightly complicated formula. But we can work it through. So here's my formula. The probability of getting a success x number of times is n factorial over n minus x factorial times x factorial times p to the x q to the n minus x. So first off, what exactly does this mean? Well, first, what exactly is n factorial, this n exclamation point? Well, 1 factorial is just 1. 2 factorial is 2 times 1. 3 factorial is 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. And you can see how we can continue this pattern. So, like I said, this formula is super complicated. But we're going to do a couple of examples of this, and then we'll show an easier way to deal with these. Let's suppose we want to toss a coin 3 times, and we want to find the chance of getting 2 heads. This is something we've calculated in the past, and we got 3/8. However, we're going to do it using this formula. So there are 4 values we need to know to use this formula: n, x, p, and q. N is the total number of things we're doing. We're doing this 3 times. X is how many successes we want. We want 2 heads. P is the probability of getting a heads, and then Q is the probability of not getting a heads, each 1/2. My formula then says 3 factorial over 3 minus 2 factorial times 2 factorial times P to the x power times Q to the n minus x power. So this is going to be super complicated, so I'm going to suggest using a calculator to figure it out. This first thing here, this fraction, is going to turn into a 3. So 1 over 2 times 1/4 times 1/2, which ends up being 3/8, exactly what we expected it to. So we could have done this example by just listing out all of the possibilities. There's not that many, there's only 8. But what if we want to do something more complicated? Let's look at another example. So in this case, we have a group of 50 students. We know that in that group of 50 students, 13% of them are freshmen, and we want to randomly select 10, and we want to know what's the chance we have all freshmen out of this 10. Well, n, x, p, and q. N is the total number of people that we have, 50. X is the number of people we're selecting, which in this case is 10. P, the probability of a success. Well, we're considering a success being a freshman. They're 13%, which means 87% are not freshmen. Our formula then says n factorial over n minus x factorial times x factorial, all times p to the x power times q to the n minus x power. So like I said before, you probably want to use a calculator to figure this out. And whenever you do, you get 0.054. So there's a 5.4% chance that these 10 people you selected at random are all going to be freshmen. So this was extremely complicated. And imagine that we want to know the chance that between 5 and 10 are freshmen. And so then we have an even more of a problem. So let's see if we can figure out a better way to do this. And the answer is we can. Luckily, people many years ago put up tables that can help us sort through these things a lot easier. we have full tables with binomial probabilities, and so now we just need to understand how to use them. Let's do an example and try to use our table to figure it out. So here I have 60% of people have college degrees, and we have a group of 15 people. We want to know what's the chance between 5 and 10 have degrees. So in this case, we have an N, an X, a P, and a Q. N is the total number of people we have, which is 15. P, the chance they have a degree, and then Q, the chance they don't. And then in this case, X would be a 5, 6, 7, 8, 9, and 10. So we really don't want to use our formula here because we'd have to use the formula where X is 5, again for X equal to 6, again for X equal to 7, all the way up to 10, and then add up all of these numbers. And that's super complicated. But let's see if we can figure out how to use the table instead. Here I have a binomial table and I want to sort through. So if we look, we can zoom in. First off, the first column that you see is N. We had N to be 15, so we need to keep scrolling until we see an N of 15. And here it is. The next thing we noticed is the first row across the top deals with probabilities, and this is the probability of P. Our probability of P was 60, so we're only going to look at the 60 column. And then we have X. And our X value is going to start to deal with our probabilities that we want. We want it between 5 and 10 people. So if we look, here's the probability of 5, 6, 7, 8, 9, and then 10. And so then all we want to do is take these numbers and add them up. And when we do that, we get that our final answer is 0.7734. So the probability that between 5 and 10 people had a college degree is just over 77%.